Hi, and welcome everybody to this session of the New York Metro Joint Cybersecurity Conference. It's great to be back. Unfortunately, not in person this year, hopefully next year, and look forward to seeing everyone again. First of all, I'm just going to apologize in advance nowadays for any commotions, kids, animals, gardeners, and the like. That's just common challenge these days, and we'll just plunge on regardless. To get started, today's topic is understanding AI and the risks and rewards around AI. And what I think is really interesting is as we go through it, we'll talk a little bit about the overlap between AI and cybersecurity. And there are some that are more obvious perhaps than others. And so I thought it would actually be interesting to talk about some of the different ways in which that's true. Certainly, many of us who are technologists are looking at AI in its own right as a very important advancement in computers and technology and information processing. But in terms of cybersecurity, there's incredible applications of AI in cybersecurity. But what really, to me, is really interesting is that many of us and many organizations, both in the private and public sectors, are starting to tackle AI and what that means in terms of designing and implementing the technology behind AI, what that means for society, what that means for our laws, what that means for our standards and our responsibility in how we use the technology. And so I think there's a lot to be learned from the progress that we've made in cybersecurity, especially over the last 5, 10, and 15 years, in looking at a new field within computing that was relatively modest going back 10, 15 years, and a lot of the development of standards, of laws, of practices around cybersecurity. I think it's really interesting as we get into AI to start thinking about how we can leverage what we've learned there and use it here. And so we're just going to start and jump right into risks and rewards. And we can start with rewards first. And we'll talk a little bit about how AI works. That's certainly important. But just cutting right to the chase here. AI is an incredible potential, offers incredible potential as a force for good. So you take a quick look around in how it's being used. And for example, here in the healthcare space, AI is being used to process vast amounts of healthcare related data, whether it's drug data, whether it's patient data, whether it's sense scans, MRI, and other forms of scans, and developing incredible analytics and predictive capabilities around that. And especially now with the pandemic, it's been applied in many ways to try to help get ahead of a lot of the treatment issues, the drug issues that are being tackled on an extremely expedited basis. If just look around, here's a good Forbes article from earlier in the year, talking about some really overarching, major global issues that might be tackled in various ways through the use of AI, whether it's accessibility for people with disabilities, addressing climate change, environmental issues, hunger issues, human rights. This is like the hit list of the UN's priorities, and the Forbes article actually goes into thinking about how the different ways AI applications can be used to advance these causes. So incredible force for good. And as we talk a little bit about how it works, that might become more apparent to all of us. But certainly, as with most technology that can be used for good or for bad, AI is no exception. And so there are many ways that we're reading about and learning about how AI might be used in a less than positive way. So here's an article that was in the New York Times earlier in the year about a company that was able to scrape millions of pictures that were publicly available through social media networks and the like, and use them to identify individuals using facial recognition technology built around AI, and then started licensing that capability out to law enforcement, but to many other private organizations as well. And so, you can see how this ability of facial recognition on a massive scale could create the potential for surveillance issues, privacy issues, concerns along those lines. So when this news came out, it had a pretty dramatic impact in the public eye and around how AI can be used in ways that are, intrusive or dangerous. And the story gets worse. And so then we read about how the technology behind this AI was apparently exposed, or some of that technology was exposed in a cybersecurity incident. So, not only do we have an AI, maybe by the company that designed it, being used in a way that may or may not be okay, but now you have the risk of a really potentially dangerous AI that's now out in the wild, or it being taken by bad actors who might use it in even more dangerous ways. Of course, when that happens, then the lawsuit starts. Now the company starts getting hit by a whole host of lawsuits, which has started early in the year and are continuing now, many months later, to continue new cases, new allegations. Companies that had licensed and used the technology getting hit with lawsuits for their use of the technology. And so, things roll on. And after that, investigations, now government investigations start up over use of the technology. So if you just think about that, you can imagine a company, startup, or even a strong, relatively strong known brand in the AI space or in the technology development space, finding ways to leverage AI and what they think is really innovative, incredible new technology being leveraged, and somehow the way they use the AI gets perceived by the public, whether right or wrong, gets perceived as being dangerous or not in a good, favorable way. And the next thing you know, that organization is in a world of pain and will be lucky to survive. So when we start thinking about our own organizations that are all being pushed a million miles a minute to leverage new technology and leverage AI and start sticking AI into every piece of software that we have, we need to be thinking about, well, where can this go wrong, and what's going to happen if this does go wrong within our organization. And we'll talk a little bit more about that. Here's another for the cybersecurity folks, familiar with the social engineering side of the world. There are bad actors using AI to actually create fake people. Not only fake profiles, but actually create images that are totally fake. So rather than going to those various services where you can just buy images, but those can be vetted by the big tech companies and perhaps caught, they're literally creating new faces, new identities entirely, and using that for social engineering purposes. And here's another very interesting example. When the government started setting up loans following the COVID pandemic, what they realized is that AI technology was being used to file an incredible volume of applications for loans. And that was basically just overloading the system, and it couldn't keep up with it. So if you think about any kind of automated interfaces, APIs that are created both in the public and private sector, they anticipate a certain level of volume. They've got the CAPTCHA on, that might not be good enough nowadays. And we're seeing AI is being used to basically mimic human behavior in ways that is not anticipated when those technologies are implemented. So what ends up happening is AI ultimately gets under the microscope. Congressional hearings, tons of news articles. I mean, just millions of news articles about how it's being used in various ways, some for good, some for bad. And what that means is our organizations deal with AI, and they have to stay competitive and to keep up with technology. That really puts more of a burden on us as technologists to understand how AI works, what are the risks associated with it, and how do we really maximize the rewards that AI can present while minimizing the risks and mitigating the risks that may come from the use of AI. So I hope I've driven home those kind of key concepts, the force for good, force for bad. And let's step back a little bit and talk somewhat about how AI works and why that's important, and why that leads to kind of the issues that we've talked about. So, AI is really an evolution of how information gets processed. So, in any traditional way going back decades, you would collect data, you would store it somewhere. At some point, you would process it, perform some form of calculation, some form of analytics on the data, and then you would generate some form of output and reporting. So, that workflow is many decades old. And AI just represents the next generation of how that processing occurs and the scale at which it occurs. And why we're seeing this explosion of AI now is due to two very key factors. One is the accumulation of just huge sets of data. And so if you think about it, everything we do now is interconnected. There's computers and sensors virtually in everything that we have and use. We talk about computers, mobile devices, vehicles, televisions, cameras, aircraft, ships, trucks. I mean, anything you can think of significance is completely wired up and connected and collecting data 24/7. And so there's a massive amount of data being accumulated. Historically, it was very expensive to process that much data. But now we have incredibly cheap computing power in large respect thanks to cloud computing. So instead of having to build your own supercomputer, you would simply go on to Amazon or Google or Microsoft's cloud environment or some other service provider, and perhaps for as little as $4,000 or $5,000, you can spin up the equivalent of a supercomputer and perform a process on vast amounts of data within a period of hours even. And so the ability to combine huge data sets with this processing power so cheaply allows us to perform analytics using AI technology in a way that's never been possible before. So how does AI work? Historically, we would write computer programs, which were essentially commands, and they would operate on data that they received. And so we knew what output we wanted. We wrote the commands that would generate that output, and really what the computer was doing was it was running your commands on some data and generating the output you expected. With AI, we're really kind of switching around the entire model of how computing works, because what we're doing is we're just creating algorithms, mostly based on probability, statistics, and other forms of mathematics. We create algorithms rather than commands, and those algorithms create mathematical models. The computer has those models, and you don't input the commands, you input the data, vast amounts of data, and then the computer, combining the data with those algorithms, will generate its own commands essentially and generating its own output. We have no idea what that output should be. or will be. And so it really changes the entire dynamic of how computers are being used. And this really is a result of the fact that when you have very small pieces of data to operate on, you want to add two numbers. Well, you kind of, in your head, you can kind of conceptualize what you need to do and write the commands to do that. But if you're talking about just billions or even more data points, what human is capable of writing the commands to handle all of that and to organize all of that and to derive patterns out of all of that and understand what the output should be. The data is so vast that we have literally, it is literally outgrown the capabilities of people to write the software to handle it. And so what we've done is we've outsourced that job now to AI. We let AI figure out what it needs to do with the data to generate results. And so this is really dramatically changing the way computers work and are used, and will therefore, unlike perhaps some other technologies that have more niche, place in the greater scheme of things, AI may very well just replace all software as we know it in the long term in really substantial ways. I mean, the applications are just endless for AI, which is why it's so important for us to really understand what we're doing with it and how organizations are going to be using it. So when you start building on these concepts using these algorithms with AI, you can create this kind of network of, you start creating different algorithms, different probability formulas, and you start plugging them together on a daisy chain. And so data points will go through a whole series of algorithms. So you only see what data is going in and you see what data is coming out. But there are what we call hidden layers of these nodes in the middle where the data is going through various algorithms and we don't really see what's happening at that point. And when we start building that and data is now flowing crisscross through these algorithms and models, that's something we refer to as deep learning. And so it just gets so vastly complicated so fast that we're really not understanding what's happening inside those nodes. All we know is here's the data we provided in the input, and here's the data we're getting on the output. We don't really understand the logic behind why we're getting certain output. So how do you actually do this with AI? Well, first you need to get some data. You need to clean it so that it's usable. For example, an AI may not know what orange or blue is, but if you color, you give every single color a numerical code like 0, 1, 2, 3, 4, 5, well, then the AI might be able to operate on that. You also don't want data that's duplicated, data that's corrupted. And so you always need to make sure your data is usable by the software, by the AI machine. We then want to use some data to put it through the AI to see what the results are, see if we're getting results that make sense, that we anticipate in some respect, and then put in other data to test it and see if we're getting the same results. Is the AI detecting a pattern on a somewhat reliable basis? And so very often when you have a data set, you'll take some training data, you'll kind of try to train the AI to find patterns, and then you'll test it with another set of data to see if you're getting kind of the same results. And obviously we need to figure out which algorithms to be used, which probabilistic formulas are kind of useful in the context that we need. There are some configurations that we can do to how accurate or how abstract those formulas should be used in terms of generating results. And once you do that, we kind of train the AI. So the AI will use those models to process the data. It will look for patterns and generate output. And that's a decision model. So that's now a trained AI. And then once it's been trained, we can put other data in, anticipate that it'll find the same patterns and generate output. And there are a number of different ways that AIs can be used in terms of different kinds of inputs, different kinds of outputs. You may use AI to just generate insights, or you may actually use AI to generate insights and then make decisions based on those insights. For example, should it approve or deny a loan application? So not only is the AI making a prediction about whether or not that candidate who's applying, is a good or bad candidate for a loan, it might actually make the decision on whether or not to grant the loan application without any human intervention. So putting it all together, and it's really helpful to kind of see how these pieces come together, because this comes up in business proposals, this comes up in contracts, who owns what piece of AI technology, who's responsible for what. But we'll start with some raw data. We'll transform it, we'll clean it up, scrub it, as we mentioned. We'll apply some models and algorithms to that. We train it. And then we may continually, as you see here, continue to train that model again and again and have it improve itself over time. But we can also deploy it to a particular use where it's getting data and then actually making specific insights or decisions based on the way it's been trained. And so this is kind of how it comes all together. And we need to understand, what the challenges are with AI and where things go right and wrong. So if you think about AI simply being a combination of statistical formulas and algorithms that are being applied, you have different natural results. It's only providing probabilities, essentially. And so it's rarely, if ever, going to be 100% right. It's giving you a probability, a likelihood of results. And so, for example, there's something called technical bias, and you can see here, which should help kind of illustrate the point. You can have an AI providing results, insights, but it's kind of leaning off in a particular direction, not quite on point. You can also have something called variance, where your results are on average right on the money, but in individual cases are kind of a little bit off center. And so those are kind of more of the technical mathematical issues. But there's another very big problem with AI, and that's not technical bias, but what you might call legal bias. And so, for example, we have a lot of laws in the United States and around the world around protected classes, around discrimination, and what happens is the AI is not a law-abiding citizen in the sense that it doesn't understand and follow those kinds of rules. And so you can have an AI that on a mathematical basis has decided to discriminate on whether or not to grant a loan application because it's determined that individuals who live in a poorer neighborhood are maybe more likely to default on a loan. Now, what kind of individuals live in that neighborhood? Are they a particular minority, particular religion, and so all of a sudden you start having a situation where the AI, even if you finally got it all working right and mathematically it's on the money, you're getting results that are legally getting you into really dangerous waters. And so it's another issue that we need to work through. How do you get an AI, even once it's mathematically right, how do you deal with the fact that the AI is violating the law? And certainly what we've seen over a number of years now is the evolution of how AI is being used and how reliant we are getting on AI. So, it started with experiments, games, chess, and that was fun. Then we started working it into personal assistants, voice recognition, image recognition. It's starting to replace human functions now. So whether, as I mentioned, loan applications, detecting fraud, identifying prospective customers to market and target to, managing risk, trading on Wall Street, and we're getting to the point where AI is being used to make life and death decisions. So we have AIs that are driving vehicles, that are making medical diagnosis, that are providing test results. And so, how reliant do we get on these AIs? Are they an aid to humans who are going to be the decision makers versus AI that are the decision makers? So for example, you can think about a scenario where doctors are using AI to do radiological imaging analysis, and the AI is always on the money again and again and again. So the doctors stop maybe using their independent judgment because they're getting very comfortable with the AI being right. What happens if the AI then gets it wrong? Whose fault is that? How do you work that out? And so as we get more and more reliant on AI, we need to think about what are the ramifications of that. Now, it could be that AI gets it right more often than humans get it right. And in that sense, AI-powered cars might be safer than human-driven cars. But how do we deal with the risks around those issues, the responsibility around those issues? So let's talk a little bit about the law, and then we'll talk about the standards as well. I think that's important, especially for those of us in cybersecurity who are very focused around standards and best practices. And again, a good place for us to kind of see common threads between AI and cyber. So no real clear legal standard on AI. There's been tons of bills that have been introduced both at federal and state levels here in the US, as well as internationally in many countries. In some respect, there's a concern about the need to deal with AI at the legal level, but on the other hand, especially in the US, a lot of legislators are very nervous about messing up because they don't fully understand AI. I don't know how many people do. They certainly don't want to disincentivize companies from developing AI. We're kind of in a global race in the development of AI. And so they want to encourage it. They don't want to overregulate it. At the same time, trying to figure out how do we deal with it. So, one liability challenge you can think about is, we have centuries of case law and history on laws that were developed to manage human beings, standards of care. We understand how humans, for the most part, think and operate. There's a concept of responsibility, for humans for their own actions. How do you start doing that when you think about machines? Are they responsible for their own actions? Where's the due diligence standard? Who do you apply that to? The AI, the developer, the user of the AI? And so a lot of those issues haven't quite been worked out. And this kind of goes to another key issue is who's at fault, or really who's responsible for AI? And, those of us, again, in cyber, when you see supply chains, right, you can have a whole series of AI designers and developers of different AI technology components that are being pulled together. Then you have the data providers and the sensors that are providing the data being used in AI. You have the manufacturers and the sellers of AI products. You have the purchasers and the users of AI products. And so you have all these different entities involved. And how do you start figuring out allocating responsibility among these different entities? Where do contracts have their role? Where does the law have its role? If something goes wrong and everyone points fingers at everyone else, how do we navigate those issues? And it's, in some respects, we've dealt with that in the law in other contexts, but AI presents some new and different scenarios to think about. So here's a few case studies that we've seen and that we've been looking at and that are important to think about. So one example, and this is very common, is we want to advertise and market to consumers. And by having more data about consumers, we can analyze that data, make predictions, who's more likely to purchase a particular product. So, a good example is if you're selling, high chairs and cribs, you might want to look at data that would give you some prediction around consumers who would be having babies and in the market for those products. So you may not have the specific, data points that you want, but you might be looking at age, marital status, and things of that nature and trying to make predictions. And so what ultimately ends up happening, though, is the AI can get it wrong, or as we talked about, the AI might start discriminating against certain groups. A lot of challenges can show up here, especially when you start getting into things like renting property, selling houses. What happens if your advertisements all of a sudden cut out entire sections of the population based on race or religion or age or other factors because your prediction engine decided that they're not good candidates for a purchase and worth your advertising dollars. And this really is this issue of legal bias. So we talked about the AI nodes on the inside, not really knowing what goes on in there. We just know what data is going in. And then we've got this black box, and then we've got output, which may be, let's say, a loan getting approved or denied. And there's actually a case that the federal government has brought against Facebook over housing discrimination, because advertisers were able to go into Facebook and select market segments that they wanted to advertise housing or rental properties, and the allegations are that those levers that advertisers were able to toggle on or off to target a specific customer segment were inherently discriminatory, and either discriminatory just inherently, or they just resulted in disparate impact. Essentially means protected classes are getting impacted in a biased way as a result of how those technologies are being leveraged. Here's another kind of big one, and this was in the news not too long ago. The police used an AI technology, facial recognition technology, to try to identify a man on a surveillance footage that captured a suspect involved in some wrongful or unlawful activity. The AI found identified who the suspect was based on its database of images, and the police were able to go to the suspect's house and arrest him, bring him down to the police station, throw him in jail, and then eventually find out that the AI got it wrong and they had arrested and put the wrong person in jail. And so we start thinking about scenarios like that, and that could increasingly happen as people get more reliant on AI. Now, certainly the police have arrested the wrong person in the past. That's happened many times. It happens routinely and over many years, and people have been convicted and then discovered to be innocent. And so it certainly happens with humans. And what we're finding is it can also happen with AI, and we need to start worrying and dealing with those kinds of risks. So where are we? We're looking at the laws, and the laws are, maybe a little bit not sure of where to be around AI. We're trying to apply our existing legal, our existing laws, whether it's statutes or case laws, to try to apply them to the AI context. But where are we on the standards? So there's a lot of developments going on, and really a lot of action in the last couple of years to kind of be mindful of. NIST, a great cyber and AI thread again. NIST really in one of the leading organizations in the US working on AI. They're specifically engaged by the administration over the last few years to start working on AI. And so they've been developing a plan for how to get to standards on AI, dealing with trustworthiness and bias issues in AI, and explainable AI, which is the idea that you want to figure out as much as you can what's going on in that black box, and how do you provide some transparency to users as to what's happening. So, you can't tell a user, well, we denied your loan and we have no idea why, right? There needs to be some way you can explain what your technology does, how your technology processes data to arrive at a decision. And so explainable AI or XAI is both in a legal sense becoming very important around transparency and notice to consumers, but also from a technical standpoint, tremendous amount of research being done to figure out how do we explain what's going on within an AI box. In the EU, there's a lot of development going on there too, and we'll talk about this in a second, but this kind of gives you a sense of like, where are the different focuses on industry standards? So, for example, here, accountability, impact, diversity, non-discrimination, transparency, privacy issues, because a lot of personal information is being processed by AI. All of these issues kind of need to be managed within an AI framework, and ethics around the use of AI. So, with that, we're seeing more kind of legally oriented guidance coming out. The FTC has in the past done a lot of work around big data. Now they're kind of shifting that focus to big data in the AI context, and they recently put out some guidance around that, but we're talking fairly high level guidance at this point. The White House has come out with AI principles. Again, high-level guidance. They don't want to mess with or deter companies from developing AI, but at the same time, they want companies to be aware of what their risks are around AI. DoD is very involved in the use of AI within the military and defense context. Securities industries looking at AI, medical industry, FDA, and the HHS in the US are looking at the use of AI in medical devices, the use of AI to process patient information and things like that. So there's a lot of work going on, but it's still fairly high level and at the guidance level at this point, you could say. In the EU, similar activity. There were those ethics guidelines that I pointed to before. They've recently come out with a white paper on AI, trustworthy AI, again, dealing with the bias and discrimination kind of risks around AI, and trying to come up with a framework that the EU would follow in the development and implementation of AI there. In the UK, actually, they've done a lot of work here. The ICO, which is the privacy regulator in the UK, is actually taking a close look at AI, working on bias issues, working on, again, explaining how AI works, that XAI issue, and thinking about it in the personal information context. How do you throw millions of people's personal information into some AI system and then protect the privacy of those individuals? So what we see here is this kind of conceptual approach of starting at principles, the ethics principles, the guidelines around that, what are the issues that we need to grapple with? Working on how do you get from there to policies? What should your company policy be on the use of AI? What are the do's and don'ts? How can you explain how the AI is being used and what it's doing? And then, we're working towards standards and regulations. There's a lot of work still to be done. How do you do due diligence around AI? How do you test AI? How do you manage risk around AI from in accordance with the standard? And then, once we get there, the natural next step is going to be regulation. If this is the standard of care, the standard of use, well, now there's going to be a law that says you need to follow that standard. If not, there's negligence, there's a failure of due care, there's product liability. So that's a progression that we're seeing, but we're still somewhat early on here. And the challenge is that for most of our organizations, they're moving so far ahead with the technology that we're trying to catch up here with the principles and the policies and the standards to keep up with their actual use of AI. So here's really my parting thoughts on the subject. And this is why, again, I see so many common threads with cyber. It's about risk management, and that's what cybersecurity is. It's managing risk around protection of information. And here we're dealing with different risks, but ultimately our job as technologists and as lawyers and as other professionals in this space is going to be about risk management around the use of AI. Again, maximizing rewards, but mitigating those risks. It's going to be about people, process, and technology. All those factors, training people, understanding they're aware of the policies, the ethics, the guidelines, putting in processes in place in an organization to deal with the use of AI. And that means licensing AI from third parties, developing your own AI, selling AI out to your customers. What are the processes that are going to be built around that and how AI is being used? And then technology is just understanding how the AI is being implemented, what aspects of AI technology. There's a lot of AI software out there. Some are better than others. Some are better in particular contexts than others. Understanding that technology and how do we leverage all of that technology. And so, like cybersecurity, expectations are going to grow over time. What's really incredible in cybersecurity is that the expectations that the public has, that courts have, that business customers have around your cybersecurity practices have grown incredibly in the last 10 years or more. And so, the kind of things that were acceptable 10 years ago in terms of security practices are downright negligence nowadays in many instances. And so AI is going to kind of follow likely a similar curve where maybe early on AI mess ups will be somewhat acceptable, but as time goes on, there's going to be less forgiveness around that. And with that, we're going to see the guidance that we're starting to see now evolve into standards and then evolve into laws. And that's where we are with cybersecurity. There were best practices. Now we've got standards. We've got NIST cybersecurity framework. We've got ISO. We've got COVID. We've got a lot of other frameworks. And cybersecurity is increasingly finding its way into legal statutes and legal requirements. And so AI going to be on a similar path. And I think a lot of us in cyber will find ways to leverage what we know and the experience that we have in cyber to kind of maybe make that path for AI a little bit easier, leverage that experience and use it to deal with AI because it's going to be inevitable, for all of us in our careers, in our lives. So with that, we'll probably open up for some questions, and thank you, everybody.
Sure. And Mark, I actually have some questions for you if you have time.
Sure.
So I actually, I was very involved with Clearview at one of my previous employers, and they were using it to find and fight ATM robberies.
Mm-hmm.
Now, the fact that Clearview source code is out there, making Clearview cease and desist, right, for law enforcement means that the only people who will have it were basically the nefarious actors. So, I mean, do you find that that's going to be a disservice to the community?
Definitely. So that's where we frequently see this issue of trust around national security, crime, fraud prevention, loss prevention activities, where a lot of this kind of information, personal information, is going to be used in a reasonable and responsible way. And so, and we deal with this. We have clients that have stores, they have cameras in their stores, they have, shoplifters, they have people committing fraud online. And so they want to use technologies like this or other AI technologies to flag issues. And that's in the interest of everyone in many cases, because a company losing millions and millions of dollars to fraud and theft is going to pass on those costs to their customers in way of higher prices, or their shareholders are going to lose out because they're taking a hit every quarter. I mean, you think about how much money the banks have lost on credit card theft and fraud over the years. They need technology. They need AI, ever more sophisticated technology to combat this fraud. So there's a need for it that's legitimate. And the question is, can we implement that but preserve trust of the public in order to do that? If the public sees this technology being used in egregious ways or concerns that it's going to be used that way, that creates a lot of problems. I think encryption is a very similar issue, right?
Gun control too.
Sure. I mean, and there's a lot of issues where, and it's interesting because if you look at some other countries, they may be more acceptable and tolerant of some of these technologies being used by the government because there's a higher level of trust in the government. There are other countries that there's zero trust in the government. They consider the government to be complete, dictatorship and fraud, and there's zero trust. And so the United States falls out somewhere in the middle. And we need to navigate those issues.
Cool. The other interesting, and I love that you brought up this idea of legal bias, right? Where the mathematic is correct, but it might be legally wrong. And, the scenario you gave was advertising. And advertising is an interesting scenario because there's a lot of media around what's considered biased advertising or not, but yet a person with a company with a commercial determines the demographics of the channels they're going to advertise on television, right? And right, so they're making these decisions every single day, targeting certain demographics, whether by race, religion, color, because television has those segregations in their channels. So why is AI-generated advertising have that legal bias or legal restrictions, whereas companies make these decisions every day?
So I think the climate that we're in is changing, and we need to be sensitive to that. So people are much more sensitive to social justice and the ethics of how the population is getting kind of perceived and targeted in a variety of contexts. And so, if there's a new product out and it's discovered that the product is being marketed to men 85% of the time, and women are kind of losing out on opportunities. Or think about it, if you have an organization that's marketing, that has job openings, and they're posting them through Facebook or some social media network, and 85% of those advertisements are going to men, right? All of a sudden that creates a perceived issue. Now you're right, if 85% of the people watching a television channel, because it's the middle of a sports, it's the middle of a football game, and use a higher, percentage are going to be men. That's been going on historically for decades. And so, where do you draw the line, I think is the question you're raising. And where I see a lot of issues coming up is where you're starting to target at a individual level basis. So you are targeting specific individuals for ads. And that creates some concern that certain individuals are being targeted, other individuals are not being targeted, as opposed to you're broadcasting an advertisement and just, you can never get a perfect balance of every kind of, form of the population, in any particular advertising venue. So, again, that's where the issues come out. And I think what's really hard is that a lot of companies are getting innocently tripped up. So they mean well, they're trying to do the right thing. There's no intention in any respect of discriminating or resulting in any disparate impact. And they're shocked to find out that, something they did with the best of intentions has been taken, in a bad light because the results were in some respect potentially discriminatory. Another thing that we've seen is, you're an organization, you build a technology, you sell it or you license it, and it gets used in ways you didn't anticipate. Or frankly, it gets used in ways you didn't authorize. So, you provide it to AI technology to do certain kind of analytics, and then you find out that the organization that licensed it from you is doing something entirely different from it, beyond the scope of the license. And now your company ends up in the news because you were the provider of the technology, right?
Yeah, all the time. Yeah.
So, that's where the kind of risk mitigation comes in, right? How are you going to manage this, these events when they unfold? And, I think another kind of challenge for organizations is that something like this happened 5 years ago, you might have weeks or months to deal with it. Now, within 24 hours, it could blow up on social media and you're all over the place, and you don't even have a chance to figure out what's going on. And the organization is being covered in the news, and there's all these exposés about it. And you barely know what's going on. You wake up in the morning and your email box exploded and the CEO wants to know
Internet time.
what's
Yes.
going on. Yeah. So that's where, again, cybersecurity, you got your incident response plan. You have that ability to react very quickly and effectively to an incident. Do you have an AI incident response plan? If something explodes, and not strictly AI, but, in a similar vein, something goes wrong with a customer, with your AI, do you have a response plan? Do you have a way to kind of backtrack? Is your system so kind of solely based on it that there's no alternative? You can't switch the trains onto a different track while you troubleshoot. And those are kind of the risk mitigation and the best practices that I think cybersecurity can play a really instructive role on.
Well, Mark, thank you very much. And, it's always an interesting conversation to have with you.
Sure. Thanks for having me. Appreciate it.